Now we will solve the problem number 29 from the chapter 27 survey book. Problem number 29 is fifth is a mm, 50 watt heating coil designed to operate at 110 volt. Okay, that is very important. Nichrome wire of diameter 0.5 millimeter in a diameter. Assuming that resistivity of the from constant at 20, acha, okay, value, find the length of the wire. Okay. We have to find the length of wire. And we know that to find the resistivity, we must know the formula, that is resistance is always equal to rho length, and because we have to find the length, and that is area. And this implies that length is equal to rho A uh, resistance A over L. Okay, sorry, resistance A over resistivity. Okay, sorry, resistivity. We have to find the L. But unfortunately, firstly, we have to, resistance is not given. Firstly, we have to find the resistance. And for this resistance, we know that we have given that P is given as 500 watt. Operating voltage is V is 110 volt. Okay. So to find the resistance, we know that we have to find the resistance. Okay, from this, because here we have to use this resistance. Actually, we have to use this resistance. So that's why we have to find the resistance, and resistance is as we know that P is equal to, yes, we know that P is equal to I square R, or you may say that I have used the previously IV, or you may say that I square R, and you may say that I square R square over R. That may be as a V equal to I R, so that may be right in the form of this. From here, so resistance will be equal to, yes, that will be V square over R. Okay. And V is given, already given, V square over V is given is 110 volt, and not P. Okay. So, and P is 500. So this will become, sorry, I'm wrong. Here is 110 volt. We have to take the scale, and uh, this is of power is 500. So by calculating, the value is 24.2 ohm. So this will be a resistance. Okay, and we put this value, this in this resistance. So by putting this value, so area, to find now, the second thing is, what is the area? A is uh, actually, sorry, area will be calculated. A will be, yes, A will be area of, because uh, diameter, ठीक है, वो designed to operate from in nichrome wire of this diameter. Okay, so area will be as we know that that will be a pi r square, or you may say that pi p by 2 r square, because diameter is given. Here you may say the diameter is actually the given, not so that's why we have to write this. And so mm, so pi d is as we know that d is 2.5 10 raised to power minus 4 divided by 2 square, because this is no, sorry, I am wrong. D is given 5 millimeter, mean 5 multiplied by millimeter 10 is to power minus 3. Okay, yes, centi 2, and this will be 1 minute. So that will be divided by 2 square. Okay, so this will be area, and rho, as we know that rho, that is resistivity, that will be equal to for this element, that will be 1.10 raised to power 1 point, sorry, 1.5 10 raised to power minus 6 ohm meter. Okay, by putting all these value, we will get the resistance, sorry, not we have resistance is given, we have to find the L. The length will be R is 24.25, uh, area length pi, area is pi of 5 10 raised to power minus 3 over 2 square, because half of okay, and divided by rho is 1.5 10 raised to power minus 6. So the final result is 3.17. So this will be the length. The B part is what if the now we consider the variation of resistivity with temperature when power is delivered to the coil of the part A when it is warm to 12 centigrade. Okay. So to solve the B part, what is the B part? So to find, we have to find in what is the power delivered to the coil. We have to find the power delivered, but there is a relation. You know, the we consider the variation of the resistivity. Firstly, we have to variation of resistivity with the temperature. What will be the power? What if we now consider the variation of resistivity? So firstly, we have to find the variation in resistivity with temperature. Okay, so firstly, we will find the variation resistivity, as we know that resistance vary according to this formula. Okay, uh, the initial, and we know that we have to final, ri is I have already find Ri is Ri is where is R? 1 minute. This 24.25. Ri is 24.25 1 plus alpha uh, Tf and Ti. Alpha, I have already explained the alpha for this element is 0.4 10 is to power minus 3. This is uh, coefficient of temperature, okay. 0.4 10 is to power minus 3, and change in temperature will be that from 1200, 1 minute, 1200, not 12,000, minus I think it's 200, no, not 20, not 200, 20. Okay, so this will be equal to this. So 24.25 1 plus 0.4 10 raised to power minus 3, that will be a 1180 1180. So by calculating all this, the result final resistance will be a 35.6 ohm. So the B part was power deliver. We have to find the P. What will be the P? We have, as we know that P is actually the voltage. Uh, I have already explained it, but as we know that that will be I V or I square R, or you may say I R square over R, or you may say that V square over R. V is 110 square, and R is 35.6. So the answer will be 340 watt. So this will be the our result. Okay. Uh, so the 340 will be the watt will be the answer. Okay. If you have any question and confusion, please put your question at the comment. It will be highly appreciated. Thank you very much. So the now we will solve.